Okay, as I told you last time, we had done interval estimate of population mean under the major topic of interval estimation. Let us go ahead and check interval estimate of population proportion. Okay, as you know, both the sampling distribution of proportion and of population mean follows the central limit theorem. Okay, that means it will be having a regular normal curve distribution will be there in both the cases. Okay, so let us see some formulas. Now, under the interval estimate of population proportion, as I told you, it follows the central limit theorem. So, at 95% of your level of confidence, or you can say as 5% of level of significance, the confidence interval will be written as P plus minus 1.96 sigma p. Now, in this case, what is 1.96? It is the value of z, okay, which we can find from the normal distribution table. And you have to go in the reverse order to check for the 95%. When we say 95%, it is actually including both the sides, that is the positive side and the negative side. And when you want to refer to the table, while referring to 95%, actually it will be 95 divided by 2. So that is around, say, 47.50%. And when I convert this into probability, it will be 0.4750. Okay. So I need to see this value in the reverse order in my table and see the corresponding value for this 0.4750. And if you look at that, you'll get this value as 1.96. Okay, that is how we get this value of Z, the variate, the standard variate. P in this case is nothing but your sample proportion of the desired attribute. So if you are looking for the mean and all, then it will be the sample proportion of the mean. Or you can also say the sample proportion of defectives in the sample. Okay, so P stands for that. Then we have the sigma P is there, which is your standard error of proportion. And it has a formula. So you can note down that formula as well. So sigma P, which is your standard error of proportion, which is given by this formula, sigma P equal to square root of pi into bracket 1 minus pi divided by small n, where your small n is nothing but your sample size and your pi is your population proportion. Now, if you say that it is 95% likely that the population proportion will lie within this range, okay, that is given range, then for 99%, as you know, the value at 99% level of confidence, the confidence interval will lie between P plus minus 2.58 sigma P, right? If you remember last time, I had shown you this value 2.58, or you can also take the value as 2.575. Okay, and this is at the confidence interval to find the confidence interval at 99% level of confidence. And if I change this percentage to say 90%, then the value of Z is 1.65, or you can also take 1.645. So in both the cases, please remember the only value which is changing in the formula is the value of Z. Clear? There are some points to be noted uh, which are very important, and especially for your large samples. When we say large sample, the value of NP, which is greater than equal to 5, and NQ is also greater than equal to 5, where P is your probability of success. And because it is probability of success, Q will be, of course, 1 minus P. Okay. And where do we get this? We get such type of distribution binomial. So it's then the binomial distribution is approximated to a normal distribution. Clear? Now, the property of presence of the desired attribute can be considered, say, defectiveness in an item can be considered as probability of success, that is P. Okay, and Q, as you know, is for failure. Okay, clear? We also have a population proportion, which is given by pi. Okay, is if it is not known, then we can make use of the formula here, sigma p equal to square root of p into bracket 1 minus p divided by n. This will help me get the values of your sigma p. Okay, if sigma p in the previous example, the formula was square root of pi into bracket 1 minus pi divided by n. Okay, so if pi is not known, that is your population proportion is not known to you, then we can make use of the sample proportion p. Okay, that is how we can use this formula as well. And the last point says that p plus minus sigma z sigma p gives you the interval estimation of the population proportion pi, and sigma p represents the standard error of estimation. You can call it as a population proportion at a given confidence level. Now, the confidence level can be given in percentage, or it can be also given in decimal points, or you can say probability as well. And your level of significance can be derived from the confidence level. The total should be always 100%. So it is simple, 100 minus confidence level will give me the level of significance. Now it is very simple equations or calculations. Let us take one example based on this time estimate of population proportion and check how we can go ahead and solve the problem. Okay, the functions are very simple, and the only purpose here is to find the intervals. Okay, so if I have to find the confidence intervals, make use of these functions. The value of z is important. The rest of the formula is very simple. Let us take one example based on this topic. Note down this problem. Now, in a random survey of 70 employees recently joining a BPO firm, 50 were college-going students. Estimate the percentage of college students among all the newly joined employees. And there are two confidence level given at 0.95 and at 0.99. Okay, that means at 95% of, you can say, confidence level and 99%. So please give a try here. The sample size you already know, the sample size is given to you. So the value of n, which is the sample size, is 70. Okay, and you can say the number of college students in the sample is given as 50 there. Okay, so using these two values, you can calculate the sample proportion of students. So what will be the sample proportion of the students here? Any answer? Any answer, guys? You can put in the chat as well. Simply, it will be 50 divided by 70. Okay. So if I divide 50 by 70, 5 by 7, just check what the value is. That will be nothing but the value of P, that is the sample proportion of students. Okay, something in the chat. 0.714, right? So the value of P you will get as 0.714. Now using this value, okay, we are supposed to find the interval estimate, okay, for the proportion of students. Now, what is the, please calculate the value of standard error of proportion, that is your sigma p. So sigma p, because we already have, we do not know the value of, you can say pi, that is your population proportion. We know the value of p here. So I can find the standard error of proportion using the value of p, which is given by square root of p into bracket 1 minus p in divided by n. which will help me get the interval estimate of pi. Yes, any answer? Okay. Chat 0.064. Any other answer? Advait gives 0.053. Fine. Any other answer? Okay. If you look at the calculation, it will be like because we got the value of PP was 0.714, right? And to find the standard error of proportion, we can say square root of P, that is 0.714 into bracket 1 minus 0.714, right? Multiply this divided by 70. It's because 70 n, the value small n is 70. Now the answer is Advait is very close by there. The answer is 0.054. Okay, please check it out. You can do the calculation once again and check the answer. Okay, so if I'm rounding it up, the answer will come as, so the interval estimate of pi can be written as 0.054. And sorry, the value of standard error. Now using this value, if I want to write the formula for the interval estimate of pi, we can write as 0.714 plus minus z into bracket 0.054. Okay, so your function now for your interval estimate of pi changes like this. Now at confidence level of say 95%, what is the critical value of z? You can refer to the table if you do not remember, because I think in maximum of the examples we have taken 95%. We have taken 90%, 95%, and 99%. So at 95% critical value of z is 1.96. Okay. So using 1.96, please calculate the interval estimate. Now this has to be for the first one, that is at 95% of confidence level. And you can put it in the chat once you get the answer. Is anyone? Kushal gives the answer as point. Is it 0.819? That is what you're seeing. Okay. Fine. Right, the other way. That is so 0.609 or 0.8. I think is 0.8 what we are getting to 0.819. Fine. If I have to say in percentage the interval, now the interval will be between 0.608 to 0.82. Okay, so we are rounding up to 2 decimal places, and that is what will be the in percentages. In percentage, it will be 60.8% to 82%, right? Now this is at 95% of confidence level. Similarly, please do the calculation for confidence level of 99% or 0.99. First of all, find out the critical value of Z. Find the critical value of Z. The second question. And once we get the value of Z, you can find out the interval estimate of pi. The only thing we have to change here is the value of Z in the formula. So it will be 0.714 plus minus Z into bracket 0.054. Okay. So find out the value of Z at 99% of confidence level. Those who do not remember the value as we have taken it before as well, 2.58, or if you want, you can also take as 2.575. Both are okay. Okay, Saurav gives me the answer as 0.574 and 851. Okay. Saurav, just check the second value, that is 0.851. Whether you're getting that. And whether you are using a 2.58 or 2.575, please let me know. Okay, 2.58. Right, fine. Okay, the answer is right. Saurabh, both the answers are right. I hope the others have also done it. For those who have not done it, I'll just show you the answers on the screen here. Please note it down if you have not done it. So let us come back. Okay, so N is the sample size, 70, and the number of students in the sample is given as 50. Now, using these two values, I can easily find out the sample proportion of students. So sample proportion of students can be given as 50 divided by 70, which gives me 0.714. Okay. Then using this, we have this population proportion pi can be written as P plus minus Z sigma P. Okay, so this is the formula which I'll be using. Okay, P we have already found out 0.714. We are supposed to find out the next value, the standard error proportion, that is your sigma P. To do that, this is the calculations which we have done. Sigma P equal to square root of P into bracket 1 minus P divided by N. And the answer rounded up is coming to 0.054. Okay. Now using these two values, the value of P and the value of sigma P, at a confidence level of 0.95 or at 95%, where the critical value of Z is 1.96, we can find the answer for the first one. So using Z as 1.96, I can easily do the calculation and this will be my answer. So there's something in the chat. Okay. 0.75 to 199%. Okay. Fine, great. Yeah, so this is the answer for the 95% of confidence level. Okay. Now for the second one, at a confidence level of 0.99, or you can say 99%, your critical value, I have taken the value as 2.58. Okay, if you want to be very precise, You can also take up to 3 decimal places, that is 2.575. No problem at all. Okay, but if the value of z is not provided to you in the question, especially when in the exams, you can make use of 2.575. Okay, so using this value 2.58, I can do the calculation, and the values will lie between 57.4% to 85.4%. Now this is at 99% confidence level. Your estimated percentage of college students is 57.4% to 85.4%. So basically, if you have seen, wherever we have to find out the interval estimate, your estimation problems are actually very simple, even though they look very complicated at the beginning. But the problems where we have to actually find the interval estimate, in both the cases, the previous example also which we took, and this one, they are very simple to solve. Okay, just be careful with the value of z. That's it. Okay, that's ends my topic on probability distribution. And the next topic which I'm planning to take is your queuing theory. Okay, now I'll just stop this screen share. Now, as you all know, everyone, you might have in your school days or college days, or somewhere or the other, you might have student queues, okay, to get some service. Right? So we will be learning queuing theory, and the actual purpose of learning this queuing theory is to analyze the queues and the queuing behavior, and using which we can easily find solutions to problems which are based on queues. Okay, so if suppose you're going to a bank for a particular service, so depending on the footfall or the number of customers walking in or the arrivals at a particular counter, we can think about whether to create multiple counters for the same service, or if there are multiple counters, we can reduce the number of counters depending on the arrival rate. So such types of problems we'll try to see when we come next. I won't start with the queuing theory today. To just give you a brief about it, there'll be two types of queuing model which we'll be learning. The first one will be based on a single server. That is, we have, for example, we have only a single counter, okay, and a single queue, okay, wherein the population or the customers are infinite. Like, of course, there are two ways of dealing with the population or the customers. Either the population or the customers will be either finite or infinite. Okay, so we are going to consider infinite customers in my queuing model. The second model which we'll be learning will be the multiple server, where we have multiple servers available. Now, this is not just on, say, the example which I gave was of a bank. Let us take off the internet. Now, whenever you ask for a service through a browser, your request goes to a server, right? And depending on the number of, you can say, requests on the server, there is always a queue. Okay, and the service is given in different ways. Now, the service given can be on first come first basis, or it can be randomly done, or even last in first out. Even that is possible, especially when we are talking about computers or servers, where for example, a stack. If I'm piling up a stack, the one file above the other. While clearing the file, the topmost file will get cleared first. So that is the example of, the last in, first out. Okay, so there are two models which we'll be learning, and there are lots of formulas which are available in Q, and basically all your problems which are based on queuing model, you have to literally mug up all the formulas, which are a bit difficult and easy also if you are making use of some shortcuts. So when we come next, we will go ahead and start with queuing theory, and also take up some problems, and the first part, that is on a single server. We'll start with that, and we'll also sense of some new terms which we'll be using in the queuing system. Okay, so that's all for today. When we come next, let us start with queuing theory, which is again the second part of your third unit. Okay, so I'll stop here today. So thank you, everyone. See you next, and we'll start with queue theories there. Thank you, guys.
Thank you, sir.